Welcome back. In this video, we're going to look at chemical bonds, electron shells, and electron clouds. So first we'll look at the configuration of electron shells and orbitals. Then we'll talk about chemical bonds. There's two types. Actually, there's more, but we're going to talk about covalent bonds and ionic bonds. And then we'll look at the primary chemicals of life, hydrogen, carbon, nitrogen, and oxygen, and just briefly look at how they form covalent bonds and facilitate the complex chemistry of life. And finally, we'll just touch on ionic bonds that form between atoms with different electronegativities. So electrons exist within clouds or orbitals, and this is just a simplified picture of the first 5 orbitals, 1s, 2s, and then 2px, 2py, 2pz. And they're much more complex than this. So electrons behave as a particle in a wave, and they have a 95% possibility of being within these clouds. And it's described by a field of science called quantum mechanics. So we're not going to worry too much about that, but just to leave it at the fact that it's very complex. Okay, and so we're going to represent the position of electrons and the nucleus with this simplified diagram where the circles are electron shells, and then the white dot represents an electron orbital with an electron, and the black dot represents an electron orbital without an electron. So hydrogen has 1 proton, which means it also has 1 electron, so it has 1 empty position in its inner electron shell, whereas helium has 2 electrons because it has 2 protons. The electric charge is always balanced. It also has 2 neutrons. So it has 2 electrons in its inner or only electron shell. And so it actually, this is the reason that helium doesn't react with other elements, because it has 2 electrons, but hydrogen does, because it really wants, if you want to put it that way, to fill that empty electron orbital position. And we'll just look at those other important chemicals for life. Carbon has 4 open electron positions in its outer shell, which means that it shares 4 electrons with other atoms in covalent bonds. And that's why it's such a good molecule to serve as the basis of life, because it can join with many other atoms and form the complex shapes required for proteins and other molecules of life. We have nitrogen with 3 open electron positions, and nitrogen forms amino acids in proteins and nucleic acids in DNA. It also forms atmospheric nitrogen molecules, where 2 nitrogen atoms share 3 electrons. And this is the second electron shell, and so it has 8 positions. So because nitrogen has 7 electrons, 7 protons, 7 electrons, it has 3 empty electron positions, so it wants to share those with other atoms in molecules. Oxygen obviously forms atmospheric oxygen and biological molecules and water. And it has 2 empty electron positions. And so one of the keys to life is that there's a difference in bonding energies in the oxygen molecule and the carbon dioxide molecule, such as is converted during photosynthesis and respiration in animals. So really that's what enables biological energy utilization. And also it's a key factor in combustion. So now we're going to talk about covalent bonds and ionic bonds, and atoms with similar electronegativities. This is an electronegativity chart. They tend to form covalent bonds. So here we have carbon, nitrogen, oxygen, and hydrogen. And so hydrogen is 2.2, and then I expanded the diagram here for carbon, nitrogen, and oxygen. So you can see that those are all somewhat similar in their electronegativity, whereas the ones on the end in the second shell, they have extremely different electronegativities. For example, lithium, sodium, and potassium are around 0.9, and fluorine, chlorine, and bromine are around 3 or 4. So these have ionic bonds, whereas the molecules of life form covalent bonds where they share electrons. But because these want electrons so badly, they'll take electrons from these, and that's what forms an ionic bond. So let's look at the simplest molecule, molecular hydrogen, where 2 hydrogen atoms share 2 electrons, and so they're stable. So this is the type of molecule that forms in giant molecular clouds, which we'll talk about at the end of this chapter and in the next chapter. And that's really a key to the formation of stars because they're heavier and they give the cloud more gravity. And here's another example of sharing electrons. So carbon, remember I said it has 4 empty electron positions, so it shares 4 electrons. So that's why it bonds with 4 hydrogens like this. And then if this wasn't hydrogen, it might be another carbon or something else. And so that's, several carbons might form a sugar. And so that's really the key to, we talked about carbon-based life. That's the key to carbon-based life. And so these are covalent bonds, which means that the orbitals are shared by both atoms. And that's how they bond. Okay, here's water. And water obviously is the most abundant substance in living organisms. Also, its properties of being a solvent and a lot of other essential properties that make it a suitable molecule for life are due to the fact that the hydrogens gather on one side of the molecule, and then that leaves a negative charge on one side and positive charges on the other. So actually, they tend to line up in chains, and that's called hydrogen bonding. So that's what causes surface tension. And they also tend to be able to be a very good solvent, dissolve other substances, among many other properties. And then let's look at ionic bonds. So remember I said that sodium was on one side of the periodic table with very low electronegativity, and this is a very electronegative atom. So what it does is, and you can kind of see why, it steals the electron from the outer electron shell, which only has 1 electron. So sodium's happy not to have that outer electron shell because really it should have 8. And then fluorine steals the electron, so it has a full outer electron shell. So that's why, like sodium chloride, sodium fluoride, sodium chloride is table salt, sodium fluoride. And then when they dissolve in water, the fluoride keeps the electron, so it becomes a negatively charged ion, and sodium is a positively charged ion. We'll see you next time.